we can continue.
మనకు వాతావరణం చేంజ్ అవుతుంది.
Okay, yeah. Just a minute. Okay, as I mentioned, it is a notifiable occupational disease. Okay. So whenever these kind of occupational diseases, whenever you notice, so what we have to do, a factory manager or in case of any medical officer is appointed, they have to inform to the chief inspector of factories. In the sense, they have to update the inspector of factories regarding this occupational disease. You will see what is the measurement and also evaluation, how you will measure this noise. If you see a source of industrial noise, before studying the methods of measure, it is necessary to know the main sources of industrial noises. What are the various sources of industrial noise? If you see the sources, one is impact. It is the most intense and also widespread of all industrial noises. The impact noise is usually impulsive, but it can be continuous, as in case of tumbling. Impact means it is a sudden noise. One is friction. A friction of process like grinding, sawing, sanding, cutting, and also turning of lathes, also machine tools, brakes, etc. Whenever two metal parts or it is getting contacted, wherever it is interacting with each other, there it will generate the friction. Then reciprocation, vibrating or reciprocating or unbalanced rotating machineries, like any gearbox or any shaft or couplings. Then air turbulence, high velocity air, steam or a gas causes noise, like any leakages or gas leakage or steam leakage. The intensity increases with the velocity of the airstream. Examples are exhaust noise from a pneumatic tools or jet engines. So the leakage of air or steam will also generate high amounts of noise. Then need of measure. Why we need to measure? So until unless if you are not measure, we can't able to control it, because we don't know what is the noise level, either it is 90 dB or 100 dB, dB in the sense decibels. Without knowing the value of the noise, we can't take any measures. Okay, similar way, the measurement is required. It improving the building acoustics, like what will happen, acoustic in the sense. So it will be covered by a certain material, so that what will happen, it will absorb the noise. It won't allow to go out from that facility. Permitting a precise scientific analysis of the enjoying sounds and giving a clear picture of identification of damage to the hearing or suggesting corrective measures to be taken. And hearing loss can be determined by measuring a person's hearing sensitivity by the audiometer. So it will gives us a values for the analysis, and also it gives us identification of damage to the hearing and also suggesting a corrective measures to be taken. So that what will happen, once you have identified, it is easy for us to take the corrective measures for the hearing loss. Now we'll see how they will method, or what are the various methods for the measurement. One is the hearing loss, which is auditory effect, and the interference with the communication, essential for safety and also productivity. And the hazard involves in the task to study a specific problem. So what will the effect? One is hearing loss. It interferes the communication. How it will interfere the communication? If there is any heavy noise or a high noise, so we can't able to communicate. We can't able to inform to our co-workers about the job requirement. One is noise dose. So these are the various meters we can able to measure the noise. If we see a noise dose meter, it is a portable instrument which can be carried in a person's pocket. A microphone can be operated from the noise dose meter body and also should be mounted close to the individual's more exposed ear. So the dose meter will happen, it will able to collect the noise levels he is exposing. How like we'll have multi-gas detectors or multi-gas meters. So where we can able to measure the noise levels or the chemical exposure. A noise dose meter display the percentage of daily allowable noise dose. A personal dose meter or miniature or integrate sound level meters. So personal will be integrated sound level meter. This integrated sound level meter, what will happen? It can able to calculate the average of the total exposure. Another one is the directly measure the noise continuously at the end on the same time read out the primary noise. Does the percentage of maximum allowable 100% over the exposed period of 8 hours. So if you see 100% in the sense, I can say for 8 hours, 90 decibels is a 100% exposure. Beside this, it is also indicates when a certain level or exceeded the maximum allowable of 140 dB, it give a peak. So whenever it is reaches the set limit, it will give a peak sound stating that you are exposed more. So this is how we can have an employee noise exposure record. So we can collect the data within a sample sheet. Okay, anyhow, I'll give the presentation, you can refer. Now, permissible limits of noise. So what are the permissible limits? So setting objectives of the noise abatement program. So we can say that noise reduction program, we can start a initiative like safety suggestions or near miss reporting. A measurement of noise levels at the workplace. And also with a moving man by measuring his doses of exposure. Like we will measure the noise levels in the various workplaces where and all he is moving. So with the dose meter, we can able to measure. And comparing measured values with the permissible exposure limits and also assessing the situation whether within the limit or needs a control measure. So once you measure, we will analyze whether these details or these values are in the limit or it has to be controlled. Controlling exposure of excessive noise and also monitoring the hearing of exposed person. First 3 steps are evaluation and also last 2 steps are all under engineering control. First 3 are evaluation, setting objectives, measuring the noise levels and capturing the measured values and taking the action. Taking the action in the sense controlling of exposures and also monitoring of hearing of exposed persons. These 2 will be the control measures. Now we'll see the path from source to the receiver. In between gap, we call it as a path or way. It will the noise will transit. And if you see a different kinds of control methods at the source, at the path, and at the receiver. In the sense, source in the sense where it is generating. Path in the sense in between the noise, source, and the receiver. At receiver in the sense at the exposed person. If you see an at source, substitution, isolation, segregation, reallocation, redesign, selection of machinery and methods, enclosures, barriers, reducing energy or forces damping. These are the various controls we can take it up at the source. If it is at the path, so absorption, attenuation, barriers, or putting the silencers or mufflers, both are same, and soundproofing, then vibration dampings, remote controls, and the isolations, keeping away of the equipments. And at the receiver side, like ear protection, medical supervision, and also audiography, reduction in exposure time, like reducing, allowing people to, excuse me, only for the lesser durations. Then exposure time, isolating worker by both changing job schedules and also giving rest intervals or giving some breaks in between the work. These are the various control methods we can implement. If you see other control methods, so other control methods will be, one second, yeah, other controls will be substitution of non-precocious tools and also a process for the pressure ones. So here we are substituting, like elimination substitution, we are using the substitution of the precocious tools or the processes for the pressure ones, like use of hydraulic drivers instead of a cam or eccentric drivers, so that we can reduce the noise. Use of rotational or preferably uniform motion instead of reciprocating motions. Instead of reciprocating, we can say a uniform motions. Then use of a V belt transition instead of a chain a chain gear transmission. Then use of lubricant bath for the meshed gear and also the forced feed lubricant for the articulated joints to minimize where the noise causes or friction. Use of lining or elastic inserts in jointing of wide minimize the transfer of vibrations, like using some rubbers or dampers to avoid the vibration. And use of plastic and also mute materials for the metal and also combination of metals, like washers in between two metals. We are using any rubber washers or metallic washers. So not metallic, leather washers or different kinds of washers, so that we can avoid the noise. Keeping fans and also engines off when not in use. When not in use, you can keep all this in a closed condition or switch off condition. A good regular maintenance by lightening loose guards and also panels. Then oil greasing replacement or also adjustment of worn, loose or unbalanced parts of machines. So we have to do the proper machining or proper maintenance to avoid the noise. Then reducing of forces and also speed. By this as well, we can able to control. Okay, these are the various other control methods. Then use of vibration dampers. Then reduction in radiating area of overall size, and the use of flexible mounting and also couplings to avoid the more noise, and use of resilient flooring in the sense suitable flooring, and also sound absorbing materials, walls and ceiling. It is called as acoustic enclosures. Then reducing pressure, turbulence, and also increase of cross section of these steams. Then elimination of air and also steam leaks, and increase in the distance from the noise sources. So these are the various ways we can reduce the exposure. So if you see here, a drill operator is undergoing a mine in exposed of the following noise level during a working day, and calculating the daily noise dose to him. For example, he is working 95 dB for 2 hours, 90 dB for 2 hours, 115 dB for 0.25 hours, in the sense 15 minutes. So how we can calculate? So this is the formula for the daily noise dose. For example, D is equal to dose 100 sigma. What do they say? 95 dB for 2 hours. What is the maximum he can expose? 95 dB. You can put in chat box. What is the maximum he can expose? Maximum he can expose 4 only, as we seen. So if 90 dB 2 hours, generally he can expose 8 hours. And for 115 dB, he can expose 0.25 and it is 0.25. So this is get cancelled. You will get 100 into 1.75. By multiplying, we can get 175%, which means he is more than exposing or more than the level he is exposing the noise. Okay. If you see the 8 hours of time weighted average, which is also called as TWA, in decibels may be computed from the dose in the percentage by means of formula. If you want to calculate TWA, time weighted average, we can use the D value by using this formula. 16.61 log 10 into D means the noise dose divided by 100 plus 90. This generally they will calculate for 8 hours of duration. Once you calculate noise dose D value, you can calculate the time weighted average, which means what is the maximum allowable per day. 8 hours, what is the maximum you can expose? Okay, this you can use in your practical experience calculations. Now we'll see vibration. Vibration, as I mentioned, vibration is a physical factor which acts on human body by the transmission of mechanical energy, which means ఏదైనా రెండు మెటాలిక్ పార్ట్స్ కానీ లేదా 2 different parts కానీ వాటిని ప్రాపర్ గా జాయిన్ చేయకపోయినా ప్రాపర్ గా మౌంట్ చేయకపోయినా బికాస్ ఆఫ్ ఆసిలేషన్ అంటే అందులో ఉండే విడిభాగాలు మూవ్ అవడం వల్ల కానీ అది వర్క్ అవడం మిషన్ వర్క్ అవడం కానీ మనకి వైబ్రేషన్ అనేది జనరేట్ అవుతుంది. ద సోర్సెస్ ఆఫ్ ఆసిలేషన్ మే బి knocks and also friction, machine parts, unbalanced or inaccurately centered rotating parts, pressure pulses, and also compressed fluids. These are the various sources of vibration. అంటే ఇన్ని రకాలైన పరిస్థితుల వల్ల మనకి వైబ్రేషన్ అనేది జనరేట్ అయ్యే ఛాన్స్ ఉంది. If you see, the sources include rotation with unbalanced loads, it will give a vibration. Misalignment of driving and also driven parts, impact of moving parts against the other moving part. For example, if you see it is in a gearbox which is moving this way, so that also will get interacted. Water hammer in hydraulic systems, high velocity air in ducts. So if it is in a high velocity air in duct also will give a vibration in the ducts. Looseness of equipment parts which causes them to rattle like a shivering. Looseness in the equipment, inside the equipment there is a looseness, the parts are not properly fixed. In that case also there will be a chance of vibration. A lack of adequate snubbing devices, flat spots or bent or bearings or steel wheels, worn or separated treads or nails or other objects, belt and also gear slippage. These are the various sources we used to get the vibrations. Now we'll see what is the effects of vibration. There are 2 types of vibration effects. One is whole body vibration. Other one is hand-on vibration. One is whole body and hand-on. If you see a vibration, the whole body due to the supporting structures. The best example is vehicle seat and also a building floor is of a former type, which vibration of any body part. If you see hand or foot due to the vibrating tool is of the later type. In the sense, if it is whole body vibration, you are sitting in a vehicle seat, so that there your complete body gets vibrated. In other case, you are operating a drill bit, or you are operating a chipping machine, that is hand-on vibration. Okay, if you see the effects of vibration are feeling of disoriented or displacement, giddiness, sickness, vibration diseases, and also sometimes fatal. Due to vibration, it may result into fatal also. And if you see whole body vibration can causes permanent damage to body, abdominal or spinal bone damage. Due to the continuous vibration, your abdominal or spinals also get damaged, in the sense backbone, and also other bones also get damaged. This vibration induced white fingers, VWF, vibration induced white fingers, known as a dead hand or Ryan's phenomena, is a damage to a blood vessels and also nerves in fingers due to a long use of vibrating power tools such as chipping, hammers, chisels, and drills. So this vibration induced white fingers due to the effect of continuous vibration, you will get white fingers because of the damage of. 1 second, guys, 1 second. Okay, I'm sorry. Yeah, these white fingers happens due to the continuous exposure of this noise. Due to that, our blood vessels get damaged in our hands. Due to that, because of lack of supply, we'll get the white fingers. Okay, if you see, these are the TLV, threshold limit values for the vibrations for the duration. Now we'll see what is the causes of this blood vessels to contract and also restrict the dye blood supply due to the fingers, creating the effect of similar to the fingers being cold. So whenever you are continuously exposing this vibration, what will happen? It is gives a similar effect of cold. Extreme weathers, you are exposing with a very -degree temperatures, what will happen? Your fingers become brittle. It can break also because of high low degree temperatures. So if you see localized vibration effects may causes changes in the bone. So your bone structure get changes and development of muscular weakness and also degrading the alternative and ulnar and also median nerves and also muscular changes, iosynchronous and also diaphanous diseases and also Kaisers. These are the various ill effects you will get with the vibration. If you see a whole body vibration, what will happen? One is increase in oxygen consumption and also increase in pulmonary ventilation, also cardiac output, difficulty in maintaining steady posture. So difficulty in steady maintaining is it you can't able to stand or you can't able to sit properly, or effects on visual acuity and also narrows the field of vision. So you can't able to see properly and also marked changes in the bone structure. So your the physical structure also get changes. Then spondylitis, deformation, and also intraterbal, and also classification of intravertebral disc. Another disease also will get affect because of vibrations. Then blood changes, hypoglycemia, and also hypochloremia, and low aerobic acid levels, and alterations in electrical activity in the brain. This also will get affected, and effects of endocrine, biochemical, and also hypothalagic systems of the body. These are the other effects which will get due to the whole body vibration. Now we'll see control measures. What are the control measures can be taken up to avoid this effects? The vibration isolators can be effectively reduce the transmission of vibration waves and properly install this isolate the source. Then reduce the surface responses like damping when isolation at the source is not possible, and vibration absorbers or dampers can be used, like it is nothing but vibration or what do you call packing pads. Reduction of mechanical disturbance that produce vibration. This is possible by reducing impacts, sliding or rolling friction, or unbalance. These are the methods we can reduce the vibration. And what is mean by vibration damping? Damping in the sense, it is nothing but absorbers. For example, it is in a concrete footing. It is a concrete footing. Here you are setting up your machine. Like if you say this is a machine beam or bottom. So here you are putting the pads. So these will be act as a dampers. So that in case of any vibration, it will take that, it won't allow to vibrate. It is nothing but a mission. Foundation of the mission should be installed on the interior block with a damping sandwich between the building foundation. But before this provision, effort should be made to balance the moving parts of the mission, which is a better remedy. So balance of the moving parts, whatever the parts which are moving inside the mission, it should be balanced first. Then you can go with this method for the effective control. And this method should be depend on the size and also weight of the machine, the frequency of the vibration to be controlled, and also the degree of isolation required. It depends on how much vibration you want to control. It depends on or also weight of the machine. Okay. With this, we have done this session. If you have any questions, we can discuss.
Sir, Praveen.
Sir,
Yes, Praveen.
sir, my name is Manohar.